Network Address Translation, commonly referred to as NAT, is used to translate a private address that is not routable across the Internet into a public address that is routable across the Internet. It conserves IP addresses by allowing the use of private addresses for inside private networks. Provides added security to your network by keeping your private addresses private. Configuration options. Dynamic, for a one-to-one or a one-to-many translation. Uses a purchased pool of addresses. PAT, port address translation. For a one-for-all, one public address assigned to an interface is used to support all private addresses on the router. Static NAT, maps an unregistered private IP address to a registered public IP address. This is used for a server on a private network that you want to make accessible to the public. Configuring dynamic NAT. If you have purchased a pool of 8 addresses to use for NAT on your router, this is the syntax for programming in a NAT pool. This is the name of your NAT pool. It is case sensitive. This is the starting address of your pool, the ending address of your pool, the word net mask, and then the subnet mask of your pool. And you type in IP Net inside source list with a number. This number you will use as a standard access control list and bind the name of the NAT pool to that access control list. The name of the pool, which is case sensitive, and then the word overload. Then you simply type access-list, then number, and that number must match the inside source list number from the previous statement, permit, and the network address that you wish to permit access to that NAT pool. Port address translation. Your company budget does not allow you to purchase a pool of addresses for NAT on your router, so you use the public address assigned to the interface going to the public network. In other words, the address going to your ISP. This is the syntax. This is the number you'll use as a standard ACL and bind the IP address of the interface to the ACL. This is the interface number used to provide translation for NAT. Once again, access list, number, the same number that you used in the previous statement, permit, the network address. The ACL number must match the inside source list number. The network address is the address of the network that you wish to access the NAT pool, or in this case, the one single address. Static NAT. You have a single address to use for public access to your server on a private network. This is the syntax. IP, NAT, inside source, static, IP address, IP address. This is your private address, and you're mapping it to a public address. Applying NAT to the appropriate interfaces. If our LAN interface fast Ethernet 00 is our private network, simply type in IP NAT inside. This allows access to and from your private network, the inside. On the serial interface going outbound, we interface it and type in IP NAT outside. This allows for the NAT translation. In NAT, we have an inside local address, an inside global address, an outside local address, an outside global address. Many people get confused with these terms. Which one is which? Well, we're going to try and simplify that. An inside local address, quite simply, is your private address. An inside global address, this is the public address that your private address is translated into. The outside global address and outside local addresses, for our purposes, these are pretty much the same. They are a public IP address assigned to a host on the outside network. We will be assigning a NAT public pool of 129.30.5.0 with a /28. That means we have 16 addresses to use to translate our private network of 10.10.10.0 into that public address to be able to be routed out of our private network onto the rest of the Internet via router 0 and beyond. In router 0, we will have to assign a static route pointing back to that NAT pool in order for network address translation to work. So we'll start off in our laptop, connect up to our router, terminal prompt, OK, enable. Global configuration mode. First thing we do is we assign our pool. IP NAT pool give it a name, which is case sensitive. So we're just going to call it R1. We give it the starting address, the ending address, because we have a range of 16 addresses, so we start from 0 and go up to 15. The word net mask, and then the subnet mask of 255.255.255.240, because we had a /28, which gets us a 240 mask. We type enter. Next, we tell it IP Nat inside source list, and this is our list number for our access control list. We just need a standard access control list. We don't need an extended, so we're going to use source list 1 because it's our first list. Specify the pool or the interface. We'll do the interface later. And the pool name, which is R1, and then we tack on the word overload. And we're going to permit our 10.10.10.0 network with the wildcard mask of 0.0.0.255. Right now our NAT pool is assigned and our access list is assigned. Now we must go to interface, fast Ethernet 0.0, and simply type in IP NAT inside. Now we go over to the outbound interface, which would probably be serial 1 in this case. And IP NAT outside. Okay, we're going to close this down for a moment. We're going to go over into this router here and assign our static route pointing back to the 129.30.5.0 network. So we'll go here, desktop terminal, enable Cisco, config T, and now we just go IP route. We're assigning a static route into the routing table. 129.30.5.0 with the subnet mask of 255.255.255.240, and then we give it the exit interface 00/0/0. If we go back and we do a show IP route, we will see that we have a static route right here directly connected to serial 0, and it is going back out to the other network over there. So we want to copy and start that. Save that into our router and close that one down. At this point, we should be ready to go through and ping from a private address over to a public address. So we're going to try that. And I'm going to move this window over a little bit. Okay, get an address, ping 148.10.10.6. And we're getting a reply. Looks quite simple, but we're going to go back to our other laptop here, and in our router we're going to exit out of this, Control Z, and we're going to go show IP NAT translations. And here we see our protocol is ICMP, the inside global address, inside local address, this is our private address, the outside local address, and the outside global address. This is who I pinged, the host on the outside. The inside global, this is the public address that I translated my 10.10.10.6 into. Another command you can use to track in real time is Debug Ip Net. We're going to turn that on. Come over here. We're going to repeat the process. Go back to the laptop, and we see that the NAT translation is taking place. To turn off Debug Ip Net, all you simply do is go undebug all. And then it turns off all debugging. Now we will demonstrate network address translation using port address translation, or PAT. We don't have the money to purchase or lease a pool of IP addresses, so we're going to use the IP address of the serial interface of router 1, which happens to be the IP address of 200.10.5.2. That is a public IP address, and we're going to use that to translate all of our private addresses in our network over here. So we're going to go into our PC, terminal prompt, get into our password, enable, config T, global configuration mode. So now we go IP NAT inside source list number 1 interface serial 0/0/1, and we can actually go in there and put in overload as well. One, because that's what source list we used. Permit 10.10.10.0 with the wildcard of 0.0.0.255. Go to our interface, IP NAT inside, go to our serial interface, IP NAT outside. Do our copy run start. Alright. At this point, we should be able to go through and do all of our NAT translations and be able to ping. So we're going to go over to our server over here, and we're going to go to the command prompt, and we're going to attempt to ping 148.10.10.6 and see if it translates for us. And it's getting it. We're going to try another command here that I didn't show you yet. We go show Ip Nat Statistics. And here it tells us the total translation is 4. 0 static, 4 dynamic, 4 extended. The outside interface was serial 001. The inside interface was fast Ethernet 00. 3 hits, 1 miss. The reason why there was 1 miss is because the switch had to map the first one. Now we will demonstrate static NAT. We're going to keep our private network over here private, but we're going to have one address, one NAT address, a public address 129.30.5.0 with a 32 mask. That means all 255s, meaning only one address. And we're going to associate it with the server here so that people over here on the PC over here can still access the web page on that server. So we'll go into our trusty laptop, terminal prompt, Cisco, enable, IP NAT inside source static, and then our private address, which is 10.10.10.3, to our public address, which is 129.30.5.0. Plain and simple. That's it. Nothing else needs to be done. Interface fast Ethernet 0/0, IP NAT inside, interface our serial port going out, IP NAT out, and this one's basically done. Minimize this. In this route over here, we have to assign a static route pointing back to that static NAT address. Must be installed in router 0 so it knows what to do with the address request when it comes over. So we'll go to this PC, terminal, get into this router, IP route 129.30.5.0 with a 255.255.255.255 mask and the exit interface, which is 0000. Show our IP route. We see it, we have our static address with the 32 mask in there directly connected to 0000. Save our information. Minimize this. At this point, we should be able to go right here and type in our address, 129.30.5.0. And it should be able to bring up our packet tracer page.